Next, I'd like to talk to you a little bit about the pH scale and what the pH scale means. You've probably heard of the pH scale in a swimming pool or an aquarium, that you want to keep the pH properly balanced. And what does that mean? What does pH mean? Or maybe if you're a gardener, you know that certain vegetables, let's say, or plants will grow in a specific type of pH. pH is also commonly mentioned in cosmetics and toiletries, deodorants and shampoos, let's say. So let's talk a little bit about what the pH scale means numerically. Now the pH scale, you notice I have up here the H in red. What the pH scale really indicates, it's a scale based on acidity. Okay, so it's really the pH plus 1 scale. There's another scale, much less commonly used, so we won't discuss it in depth here. There's another scale called the pOH scale. Okay, and it identifies and really is focused on the strength of bases. But the pH scale does the same thing. So really we just need one scale. They're just the opposite of each other anyways. So let's look at the pH scale. Okay, now the pH scale is a scale, it's a little bit backwards as far as the numbers go. Low numbers mean a stronger acid, and higher numbers mean a weaker acid or a stronger base. Okay, we'll identify here what we mean on this number line. So you can see the pH scale, it's not infinite by any means. It simply goes from a value of 0 up to a value of 14. Okay? And anybody who's a football fan knows that right in between 0 and 14 is the value 7. And at pH 7, let's kind of draw a scale here. So from 0 to 7, and then from 7 up to 14. At pH 7, what we have is called neutral, or kind of halfway pH. Okay, this is neutral pH at pH 7. At pH 7, and here's a beaker of water, what we have is an equal amount of H plus 1s and OH minuses. Okay, so if we have, let's say, 3 or 4 of these OH minuses floating around as ions in our beaker of water, and that means we have an equal number of H plus 1s. So it's kind of a standoff. Okay, there is neither more OHs or H's in this solution. They're equal in amount. Okay, so they've, in a sense, neutralized each other. And you can imagine that every one of these H plus 1s could react with an OH minus, which would make what? If an H and an OH were to come together, what does that make for us? That makes HOH, or we know it as water, H2O. Okay, and water is a substance that if we find pure water, which can be a challenge, but if we find the cleanest of clean water, then that water should, in theory, have a pH of 7. Because if it's only water in there, well, it's an equal number of H's out in front and OH's as the anion, and we have a neutral pH. Okay, so at neutral pH, what we can say is that the number of H plus 1s equals the number of OH minuses. Okay, neutral pH. Anywhere away from 7, though, and one or the other of these ions, H plus 1s or OH minuses, has an advantage number-wise. Okay, so let's just clean this up a little bit. And let's look at the low numbers. Let's draw another beaker down here around pH 0, or pH maybe 1 or 2. In this beaker, okay, at these low pHs, what we have is a predominance of H plus 1s. And we know H plus 1s are the identifier of an acid. Okay, so almost all H plus 1s in here. There may be one stray off in the corner, kind of lost its way, left over maybe. One little OH minus down here in the corner. But what's going to happen to that OH minus very quickly? It's probably going to be neutralized by any one of these H plus 1s. And we end up with just pretty much a whole army of H plus 1 ions, making this, at this end of the pH scale, a very strong acid. 0 pH being the strongest of all acids, that you can encounter. And you wouldn't really want to encounter that in the laboratory. That's a very, very strong acid that will probably eat through almost anything. Even the pH numbers 1 and 2 indicate strong acids. Okay, and we'll come back to the acid side of the scale, but let's kind of just identify from 0 to 7, we have the acidic side of the pH scale. Let's go to the other extreme. Way over here at pH 14, the highest number on the pH scale. And let's draw a beaker here, and we'll kind of include numbers like 13 and 12 at this end as well. At the high end of the pH scale, we have just the opposite. Almost exclusively in our beaker of water, or our beaker of solution, all OH minus ions, which again identify or give away a base. Okay, that identifies a substance as being basic, OHs. And we see the extreme amount of OHs over here compared to maybe just one lone, again, stray H plus 1 that's lost its way down here in the corner, which will be neutralized very quickly by any one of these OH ions. Okay, and then all we have is OHs. So this end of the pH scale is 14, even 13 and 12. These are the strong bases. Okay, so the higher the number on the pH scale, which again, it's the pH scale, but the high numbers indicate a predominance of the OH ion, indicating a strong base. Okay, so as we come back, you can kind of envision what's happening. Let's start here at the strong base scale. Almost all OHs here, maybe one H. As we work our way back to neutral pH, at this stage of the pH scale, we've got an even amount of OH minus and H plus 1 ions. And if they're even and equal in amount, that means neither one has a leg up, and we're at neutral pH. Okay, and we've made a whole bunch of water in that case. Way down at the other end of the pH scale, of course, we have a predominance of H plus 1 ions, okay, which makes it the acidic side of the scale. So this is the basic side, and the other side is the acidic side. Now, what about the other values on the pH scale? Maybe 6 or 5, or up here 8 or 9 on the pH scale. Well, if it's below 7, if the pH is below 7, below neutral, that means it's still on the acidic side, but no longer are these H plus 1s in such a greater amount. Okay, they're in greater amount than the OHs, but these would be the weaker acids. Okay, so I'll draw it a little smaller here. pHs like 5 and 6 are weak acids. And on the other side of 7, pHs 8 and 9, well, that's on the basic side, but now way up here at the strong base end. Okay, rather this would be pHs of 8 and 9. These would be weak bases. Okay, so we can see the higher the number on the pH scale that we go, the stronger the base that we're encountering. The lower we go, from 7 on the pH scale, the more acidic and more acid, the tendency towards strong acids is seen. Okay, and that's the pH scale. Again, the pOH scale, the numbers would be reversed, but the one that's most commonly used is the pH scale, okay, when making measurements.